This is 8.5 part 2. We're going to do example 2 now. So we have another situation where there's some directions happening. So again, let's just draw our little compass here to remember the direction. So we have north, south at the bottom here, east, and then west over here. So we have a captain leaving a marina. So let's just make our point. We'll make a point over here. Let's just say this is our marina. So we'll call this the marina. And the captain is driving west. So this is east. We're going this way. So we're going west. So this is our first direction, going west, for 25 kilometers. And then we go north 30 east. So we're going north, but what that also means is 30 degrees east of north. So 30 degrees east of north. So it's not straight up north. It is up, but then also with an angle of 30 degrees from the north. So it would look something like this. So we're going to draw in. I'm going to use a different color here. We're going to draw in our little compass here. This was west. We came from the east. So this pink is part of our triangle. This is north. This is south. And so the captain started to go north, but with 30-degree angle to the east as well. So this angle is 30 here. And we did that for 20 kilometers. So you're kind of telling a story and you're trying to sketch what that story is being told, what that story is trying to tell. How far is the boat from the marina? So we started at the marina, we went 25 kilometers west, then we went northeast with 30-degree angle there, 20 kilometers, and so our boat is now here. So let's call marina point A, the point we returned point B, and this new point C. That's where we are now. Let's just connect these to make a triangle. What we're asking is, how far are we from the marina currently? So after we did a trajectory, we're at point C, marina's at point A. We're asking for this measurement here, little b. And so we have 25 kilometers, 20 kilometers. This does not look like a right angle triangle. So chances are I can't use my simple trig ratios. But let's just write down what we want to do. Our goal is find B. So our first step would be, let's fill in some angles. Find angle info. We can actually find angle B because angle B in the triangle plus this 30 will equal 90. So angle B is equal to 90 minus 30, which is equal to 60 degrees. So we have 60 degrees here. And what you'll notice is we now have two sides, plus a contained angle, which therefore means we can use the cosine law to find length B here. So the trick here was drawing the question out. So now step 2 is, let's find B using the cosine law. So B squared is equal to A squared plus C squared minus 2AC cos of angle B. So this is little c over here. And then across, this is little a over here. 20 kilometers. Okay. So let's go fill in our information. So b squared. And again, normally I wouldn't write b squared over and over again, but I'm doing it just to remember to take the square root at the end. Is equal to, so 20 squared plus 25 squared minus 2 times 20 times 25 cos 60. So that means that b squared is equal to, so let's go in our calculator here. So 20 squared plus 25 squared minus, open brackets, 2 times 20 times 25 times cos 60, make sure it's in degrees, close brackets, we get b squared is equal to 525. So b is equal to square root of 525. And so what that means is b is equal to, you can do square root of 525, and you get 22.9. And I'm going to round it to about 23, not degrees. Why am I saying degrees here? We're not looking for degrees, we're looking for a side. So 22.9, our units are kilometers. Kilometers. So we can go and write our therefore statement. Therefore, the boat is 23 kilometers away from the marina. Always pay attention to what I ask you to round the final answer to. Sometimes I'll have it written at the top of an assessment, sometimes within the assessment itself, so just pay close attention to that. So 23 kilometers away from the marina, which is this length over here. So it wasn't too difficult. This is basically a typical cosine law question. You just had to make sure you drew everything properly. So now we're going to try example number 3. And what you'll notice is the more practice you get with this, the easier it'll become. You just have to make sure that you actually practice and you do a variety of problems, and you'll just get the hang of it. So we're going to start off example number 3. We might not have time to finish it in this video, but at least we'll start it off, and that way we'll finish it in the next video. So a weather balloon is between 2 tracking stations. The angles of elevation, the 2 tracking stations are 55 and 68. If the tracking stations are 20 kilometers apart, determine the altitude of the weather balloon. So we're asked to find the height of the weather balloon. So let's do the weather stations. We'll call one weather station A, and then 25 kilometers away we'll have weather station B. So this is 25 kilometers. And so the weather balloon is up in the air. And we'll call that C. And we know if you're looking up from station A, there's an angle of elevation of 55 degrees. And if you're looking up from station B, there's an angle of elevation of 68 degrees. And this makes a right angle triangle over here and over here. 2 right angle triangles. Don't assume that this length here is the same as this length. It's not, because you have 2 different angles there. This is not an isosceles triangle. You have 2 different angles here. At least right now, this side, we know, is not going to be just split down divided by 2, because there's different angles there. And if you're saying, well, what if the other side what if the other angle here is the same angle as one of these? Just calculate it. You'll see it's not. And either way, that wouldn't make these two sides here. That wouldn't make these two sides half, anyways. So we want to find the altitude of the weather balloon. So we're looking for, let's call this x. And let's try to plan out what we want to do. So our goal is find x. And so there's a few different ways you can approach this. You want to find x. It's within a right triangle. So I'm thinking maybe I could use one of the trig ratios. I probably could, but I need more information. I have one angle. I need a side, either here, here, to find that x. So that won't really work out. Maybe I can try to find the side. Maybe I can try to find this side somehow. And you probably could. So you'll notice that you actually do have this larger angle here. So we'll call that larger angle angle C, because it's from the corner C here. Okay. So that's our first step. Let's find C, angle C. Angle C is going to be equal to 180 minus 55 plus 68. So 180 minus 55 minus 68. And we get 57 degrees. So now you'll notice that we can use the sine law. We can use the sine law to find this side over here. Let's call this side little a, because here we have big A, so little a is over here. So use sine law to find length of A. Since we're looking for a length, we're going to write A over sine A is equal to, let's do angles that we know, side C over sine C. This would be side little c here. This would be side little b here because we do the opposite. So we can go ahead and solve that. So I'm just going to do that over here. So we don't know A, we're trying to find that, but we know sine of A is sine 55 is equal to C is 25 over sine of 57. We multiply both sides by sine 55. In other words, we're sending sine 55 to the other side. And that's going to be equal to 25 sine 55 over sine 57. I can cross sine 55 out here and here. And I get that A is equal to, so let's do sine 55 equals, divided by sine 57 equals, times 25. And I get 24.42 kilometers. So my A here is 24.42 kilometers. Now I have the hypotenuse, I have an angle, and I have this. When I look at this angle here, x is opposite, and A is hypotenuse. So now I can use SOH, the sine ratio opposite over hypotenuse, to find x. We won't have time to finish it in this video, but at least we'll get it set up. So we know that sine of 68 is equal to x over hypotenuse, which is 24.42. and we'll finish in the next video.